Dear students, how to determine the element strain components for a constant strain triangular elements? Let us discuss in this lecture video. Okay. For the triangular elements shown in the figure, obtain the strain displacement matrix B and determine the strain components Ex, Ey and gamma xy. The nodal displacements are given in the problem. All coordinate positions are given in the unit of millimeter. Here, the coordinate positions for all the three nodal points are given. The formula for calculating the strain components E is equal to the strain displacement relationship matrix B into the displacement matrix U. Okay. The strain displacement matrix is 1 by 2A into this matrix. So this is the formula for framing the strain displacement matrix. Okay. Here A is the area of the given element. Since the given element is a constant strain triangular element, we can use this formula to calculate the area of the triangular element. 1 by 2 determinant 1 x1 y1, 1 x2 y2 and 1 x3 y3. By substituting the coordinate positions corresponding to the first, second and third nodal points, we can calculate the area of the given constant strain triangular element as 100 mm square. Next, to frame the strain displacement matrix, we have to calculate the values of Q1, Q2, Q3 and R1, R2, R3. These are the formulae to calculate Q1, Q2 and Q3. Q1 is Y2 minus Y3. In the problem, Y2 is 15, Y3 is 5. So 15 minus 5 is 10, that is Q1. Q2 is Y3 minus Y1. In the problem, Y3 is 5, Y1 is 15. So 5 minus 15 is minus 10. Similarly, we can calculate the value of Q3 as 0. These are the formulae to calculate the values of R1, R2 and R3. The formula for R1 is x3 minus x2. In the problem, x3 is 15, x2 is 25. So 15 minus 25 is minus 10. So that is the value of R1. R2 is x1 minus x3. Here x1 is 5, x3 is 15. So 5 minus 15 is again minus 10. So in the similar way, we can calculate the value of R3 as x2 minus x1, that is 20. By arranging all the calculated values, we can frame the strain displacement matrix. Next, we can calculate the strain components by multiplying the strain displacement matrix with the displacement matrix U. Here, three nodal points are considered in the constant strain triangular element. Each nodal point will be experiencing displacement components along x and y axis. The displacement components corresponding to the first nodal point along x-axis is U1, along y-axis is V1. For the second nodal point, the displacement component along x-axis is U2, along y-axis is V2. For the third nodal point, the displacement component along x-axis is U3, along y-axis is V3. So the displacement matrix for the CST element is U1 V1, U2 V2, U3 V3. Okay. The displacement components for all the three nodal points for both the directions are given in the problem. So now we can substitute the strain displacement matrix and the displacement matrix in the strain component formula. By multiplying these two matrices, we can get the strain components along x-axis, y-axis and in the shear direction. Ex oda value eppadi calculate aagirukkum from the matrix multiplication அப்படினா, by multiplying the first row with the first column, we can get the value of Ex. By multiplying the second row with the displacement matrix, we can get the value of Ey. And by multiplying the third row of the strain displacement matrix with the displacement matrix, we can get the value of gamma xy. So Ex value mattum paapom. Ex is equal to 10 into the first element 0.001, second 0 into here the second element, so 0 into any number is 0, plus minus 10 into this third element, so minus 10 into 0.003, fourth element is 0 into 0.002 is 0, fifth element 0 into minus 0.002 is 0, sixth element 0 into 0.005 is 0. So by calculating this, we can get the value of Ex as minus 1 into 10 power minus 4. In the similar way, we can calculate the values of Ey and gamma xy.